So the advantage of the complex plane Argand diagram is that you can then think of adding two complex numbers as adding vectors. So for example, if I got z1 here and I want to add it to z2, then the answer is simply given by vector addition. So as a result of that, you can get, it's fairly obvious that various what are known as triangle inequalities hold. So the first triangle inequality is that the length of z1 plus z2 has always got to be less than or equal to the length of z1 plus the length of z2. So this is obvious in a geometrical way, that if you've got a triangle, you can think of this as a triangle, then the length of the longer side must always be less than the sum of the lengths of the other sides. It couldn't possibly be more. When this is equal, then that would imply that z1 and z2 are parallel and just lie along that side. There's another, slightly less well-known triangle inequality, which basically says that this has to be greater or equal to the difference of the two lengths. Okay. So it's basically saying that if you were to have this situation here, z1 plus z2, and you had one side which was z1, which was longer than z1 plus z2, then z2 has to come back so you end up with z1 plus z2 like this. If z2 was not long enough, then it would violate this inequality. It would mean that the difference of z1 and z2 would be larger than this, which obviously is impossible. Okay, so we also got this inequality.